Hi gentlemen, these are your notes for Unit 2, Day 4 of Pre-Calculus. If you would like to see the warm-up or review question or any of the homework questions we covered in class, go ahead and look at the finished notes from class today. So today we're going to be able to use functions to model problems. So this is going to be some word problems, your absolute favorite things to do. So let's just look at some examples. So analyzing functions, find the distance from the origin to a point on the graph. So let P be some point on the graph xy, and it's a point on the graph x squared minus 1. Graph f. So we're going to graph that function. So you guys should remember that is a happy parabola that moved 1 down. So we're just going to make a happy parabola. We're going to sketch them in, and here's my happy parabola 1 down. So that's y equals x squared minus 1. Express the distance d from P to the origin as a function of x. So we're just going to put some random point on the graph. We'll put it right here, and we'll call that the point xy. And what we're trying to do is we're trying to find its distance to the origin, which is 0, 0. And so remember your distance formula? Or you can do right triangles if you want to, right? So I went x over and y up. So it's going to be, the distance squared is going to be x squared plus y squared. And so the distance is going to be the square root of x squared plus y squared. Or if you use the distance formula, it would be x minus 0 squared plus y minus 0 squared, and then take the square root, which would, again, x minus 0 is x, and y minus 0 is y. So that's my distance formula. But I also know that y is the same thing as x squared minus 1. So if I wanted to, I could replace that y with x squared minus 1. So now my distance formula could be x squared plus y squared, but the y squared is x squared minus 1. So now I only have x's left. So now it says, what's the distance if x is 0? So we're just going to say, well, let's plug 0 in for x. So it'll be 0 squared plus 0 squared minus 1 squared. And this would be 0 plus 1, and the square root of 1 is 1. So the distance would be 1. Then C wants to know, what would the distance be if x is 1? So this is going to be 1 squared plus 1 squared minus 1 squared. So that would be 1 squared plus 0 squared, which would be the square root of 1, which is also 1. And then D wants to know, what is x if, or sorry, what's the distance if x is the square root of 2 over 2? So we're going to plug that in. I'm going to add a page so I have more room. So I have, the distance is going to be x squared, so it's going to be the square root of 2 over 2 squared, and then plus x squared, so the square root of 2 over 2 squared, minus 1, and then squared. Well, the square root of 2 over 2 squared means the square root of 2 over 2 times the square root of 2 over 2, which is 2/4, which is 1/2. So this is going to be 1/2 plus 1/2 minus 1 squared, which is going to be 1/2 plus negative 1/2 squared. Negative 1/2 squared is negative 1/2 times my negative 1/2, which is 1/4. So it's going to be 1/2 plus 1/4, and 1/2 plus 1/4, common denominator, and I would get 3/4, which is the same thing as the square root of 3 over the square root of 4. So it's going to be square root 3 over 2. And so that would be the distance if x was square root 2 over 2. All right. Next problem, find an area of a rectangle. So a rectangle has one corner in quadrant 1 on the graph of 25 minus x squared. So notice this is a happy parabola, or sorry, a sad parabola that was 25 up. So that would be his sketch. And it has another point at the origin, and then a third point on the positive y-axis, on the fourth point on the positive x-axis. So it has a point here, here, here's xy, and here's the origin. Express the area of the triangle as a function of x. Well, this is the point xy. So remember what we just did up above. X is x. And then remember, y is 25 minus x squared. So I can call that point 25 minus x squared for the y coordinate. So it would be x 25 minus x squared. So how far out did I go? Well, I went out x. So I can call that distance that I traveled x. And how far up did I go? Well, I went up a distance of whatever y was. Well, y is 25 minus x squared. How do you find the area of a rectangle? Well, you do base times height. So in this case, it would be x times 25 minus x squared. And if I distributed that, I would get 25x minus x to the third. And that would be the area of the function as a function of x. What is the domain of x? Well, it's a cubic. What's the domain for a cubic function? Well, typically it would be all real numbers. But this time we're talking about the area of a shape, right? Well, what has to be true about the sides of a shape? Well, the sides of a shape can't be 0. So we know that x has to be greater than or equal to 0. And we know 25x minus x to the third has to be greater than or equal to 0. So we want it where the area is positive and the x's are positive. And we know that 25 minus x squared has to be greater than or equal to 0. So I'm sure we took some time in class to look at those graphs and talk about what the domain would be. So you guys can look at the finish notes for that. If we wanted to graph A, it's going to be a cubic function, and it starts up and goes down. Factor would be 25 minus x squared, so it crosses at 5, negative 5, and 0. And so he's going to look something like this. That's not exactly right, but the area, the piece of the function that makes sense is going to be this. So the domain is going to be between 0 and 5. So 0 to 5 is going to be the domain. And so that's going to be the graph of it. That's just a sketch. I'm sure we graphed it on Desmos. So what value is the area the largest? Well, we need to find that maximum, that point on the graph. So we're going to use Desmos to find that peak on the graph, and that is going to be the largest area that our rectangle could take on. So a semicircle of radius r, actually, I can just use Desmos right now. So let's graph this. So we have x times 25 minus x squared was our function. So I did a decent job. I didn't go low enough or high enough. But notice my side lengths can't be negative and my area can't be negative. So the only place where the area is positive, this is a graph of the area, is on the left-hand side of negative 5 and in between 0 and 5. But since my x-coordinate can't be negative, then I'm only worried about between 0 and 5. And the biggest area that I can get is going to be 48.113 because that's the tallest the area function gets. So 48.113 is going to be the largest area. And that's when x was, sorry, they wanted the x value there. The x value was 2.887. So you get the largest area when x is 2.887, and the largest area was 48.113. All right, the next one. A semicircle of radius r is inscribed in a rectangle so that the diameter of the semicircle is the length of the rectangle. See the figure. So this is r and this is r, because those are both radii of the circle. And so r plus r is 2r. And then notice, if I go straight up and down, that's also an r. And so the width of my rectangle is also r. So my length is 2r and my width is r. Express the area of the rectangle as a function of the radius. Well, area is base times height. So it's going to be 2r times r, which is 2r squared. And then express the perimeter. Well, perimeter is when you add up all the sides. So r plus 2r plus r plus 2r is going to give me 6r. That one was nicer. All right, so installing cable TV. Metro Media Cable is asked to provide service to a customer whose house is located 2 miles from the road along which the cable is buried. The nearest connection box for the cable is located 5 miles down that road. See the figure. If the installation cost is $500 per mile along the road, so this is 500, and then it is 700 per mile off the road. So right here looks to be off the road. So this would be 700 for off-road. Build a model that expresses the total cost of installation as a function of the distance x in miles from the connection box. So here's my connection box. It's at the house. To the point where the cable installation turns off the road. So I think from here to here, so from your house to that box is, I'm assuming, is where they want us to find it. Find the domain of the cost, the c of x function. Okay, so I know that this is 2 miles, and I know that this is 5 miles, and I know that this is x miles. So this little distance right here is going to be 5 minus x. So in order to figure out, so the cable is going to go here. So it's going to go that blue line, and then it's going to go x. So I need to figure out the distance that it goes right there. Well, that distance, if I pull that triangle out, this is 2. This is 5 minus x, and I don't know that distance right there. Well, I can call that distance y, and then I can use the Pythagorean theorem. So 2 squared plus 5 minus x squared is going to equal y squared. So 4 plus 5 minus x times 5 minus x is going to give me 25 minus 10x plus x squared. So it's going to be x squared minus 10x plus 25 is going to equal y squared. Combine like terms, and I get x squared minus 10x plus 29 equals y squared. So that distance is going to be the square root of x squared minus 10x plus 29. And I only want the positive version because I'm talking about the length. So that length right here is going to be that distance, the square root of x squared minus 10x plus 29, just using the Pythagorean theorem. And then it needs to go this distance right here. And that distance right there, they called x. So the total distance that my new wire needs to travel is x squared minus 10x plus 29. So that's distance 1. And then it also needs to travel x. But each of those costs a different amount. They told me that the cost to put a wire along a thing that's not of the road was $700. So that distance is going to be multiplied by 700 to give me the cost, because that's my off-road distance. And then they said to put a wire in against the road, which was right here, it was $500. So that distance was x. So I want to multiply that by 500. And that's going to be my cost function. So I do 700 times the distance underneath the ground from the house, and then I do 500 times the distance along the road, which was x. And then B and C just says compute the cost if x is 1, so just plug in 1. C, plug in 3 for x. And then we're going to graph, so we're going to use desmos to graph that, and to see how the cost changes from 0 to 5. What values of x result in the least cost? So we want the lowest graph value. So I'm going to graph 700 times the square root of x squared minus 10x plus 29 plus 500x. So I'm going to graph that on Desmos. So we're going to go to Desmos, and it wants to know how it's changing between 0 and 5. So 500x plus 700 times the square root of x squared minus 10x, and then I forgot what the other piece was. Minus 10x plus 29. So plus 29. And they want to know what's happening between 0 and 5. Uh-oh. Oops. So y equals 500x plus 700 times the square root of x squared minus 10x plus 29. I keep hitting the, I'm trying to get out of that. So 500x plus 700, and then the square root of x squared minus 10x plus 29. And then let's see if I can get it between 0 and 5. Where's my graph? Why aren't you showing up? Where do you exist? I don't know what happened. If I blow it up even more. Well, I'm sorry, team. I don't know what's happening on Desmos. I will either remake this video or we went over it in class. So next class, you guys have a test. So reminders on how to study. You want to review all your notes. You can review my finished notes or video notes. You guys should review all of your exit tickets. And remember, you can see my comments if you go to submission rubric on Canvas on the assignment. You can click and see my comments to you on your former exit tickets. I would look over all of your homework, and I would study with your buddies.